This is going to be just a couple problems on law of conservation of mass. This is probably maybe the major idea, theory problem in chemistry. So whenever we do a chemical reaction, so you put gasoline in your car and the gasoline gets burned, or you light a match, or we mix two chemicals together and there's a reaction that happens. Law of conservation of mass, law of conservation of matter, same thing, says that atoms can't be created or destroyed. So when we burn a match, there's the same number of atoms there after the reaction as there was before the reaction. Now, the atoms might have recombined. It might be in the air, might be somewhere else, but the atoms are all still there. We didn't destroy any atoms. We didn't create any new atoms. Okay, so I apologize that this is hard to see and you have this big bright spot right here. Try and put that on my forehead. It doesn't help. But these are going to be just basic problems today. Now, you don't have to know how to write chemical formulas to do this. You just got to know that I'm mixing these two chemicals, so there's a certain number of atoms there. Those atoms have to be there when the reaction is done. So that's what law of conservation of mass is, or law of conservation of matter. That means that the same amount of mass is still there after the reaction as before. So as you're reading these, just say, this one says you have 10 grams of mercury oxide powder. You don't have to know what that is. So I'm just going to write, we have mercury oxide, which means you have mercury and oxygen as a compound together. Kind of like water is H2O, it's compound together. And we have 10 grams of that. It's placed in an open flask and heated until it's converted into. So that's going to be important. It's converted into. So I'm going to draw an arrow and say it's converted into mercury and oxygen. Now they have separated. So the mercury oxide has now split into mercury plus oxygen. You can abbreviate however you want to right now. Okay, it's split into those two things. And it says the liquid mercury is 9.26 grams. So what is the mass of the oxygen? Well, if the mercury and oxygen together was 10 grams, the mercury by itself is 9.26. Whatever's left over has to be the oxygen. So I just need to take 10 minus 9.26, and that tells me that the oxygen is about 0.74 grams. That means that in this initial compound, out of the 10 grams that were there initially, 9.26 was mercury, 0.74 was oxygen. And so whatever this stuff weighs, or what the mass of this stuff is what the mass of these over here has to be. Let's do one more. Number 17. I will move the paper down. The 17 here says, a laboratory process designed to separate water into hydrogen and oxygen. Okay, so you probably know that water is H2O. Just lower that just a little. So we're going to take water, and they're separating it into hydrogen plus oxygen. Now this is really H2, that's really O2. If I wrote the equation out for you balanced, which you don't have to be able to do right now, okay, to do this you don't have to be able to, but it really is H2 plus O2, there's a 2 in front there and 2 there. Notice that the atoms are balanced. The atoms are equal. There's 4 atoms of hydrogen here, 4 there, 2 oxygens and 2 oxygens. We'll get to that later in the year, but however many atoms there were of hydrogen at the beginning of the reaction, there has to be that many at the end. That means that the mass of the hydrogen before the reaction has to be the same as the mass of hydrogen at the end of the reaction. And same thing for oxygen. Again, you don't have to know how to do this right now. You could just write the word water, you could write the word hydrogen, you write the word oxygen. Okay, you don't have to know all these little numbers in there. But it says that the student collected 10 grams of hydrogen, and they collected 79.4 grams of oxygen. By the way, to split water into hydrogen and oxygen, you can't just heat it. You have to run electricity through it, and that will split water into hydrogen and oxygen. It wants to know how much water was originally here. Well, if they collected this much hydrogen and that much oxygen, that means that the water had to have a mass of those two together. So this plus this, again, that's kind of an equal sign here. This had to be 89.4 grams of water, assuming that all the water was used in making the hydrogen oxygen. So law of conservation of mass, however much mass is here, there has to be that much mass there. Atoms can't be created or destroyed in a chemical reaction. They could be in a nuclear reaction, but not in a chemical reaction. I'll let you try and do 18 and 19. 19 is a little bit tougher. I think it's something you can do.